All right, hello once again, Jeff Scott, formerly of Rankin Technical College, and as part of my YouTube channel, JPS-Jeff Teaches Programming, with right now its only YouTube playlist, Jeff Teaches Programming-Python, and you can see the address here. And if you put that address in eventually, or if you go into YouTube, so if you just go out to youtube.com, and you put into youtube.com at JPS Jeff Teaches Programming. You can see it below too. So if you put that in and you search, it's going to come up to my channel. I'm now at 27 subscribers, which is great. There are 46 total videos in here right now. We started by just going over what Python was all about. We wrote some very simplistic Python programs. From there, we went on and we looked at the Python keywords and again wrote some more programs utilizing those keywords. All right, we went on from there and we started doing procedural programming, and we did procedural programming, functional programming, basically using the 4 basic data structures that Python provides, those being lists, dictionaries, tuples, and sets. And then we went back and we brought in object orientation. And I did some object-oriented programs, then went back and did the list, set, dictionary, and tuple programs, redid those in an object-oriented way. From there, we went on and started doing some file programs. All right, just did a few of them. And now we're into databases. And what I went over in the last lecture was this right here. Understanding Relational Databases, a Beginner's Guide. And I'm not going to go through it again. I just went through that. Not a very long article, and it was about 50 minutes long. But what I want to show you here is this is kind of going to be my, for lack of better words, kind of my path through here. So we just went through this one right here. Understanding Relational Databases, a Beginner's Guide. Right now I'm going to go through what is RDBMS, Relational Database Management System, from Java T-Point. And I'm going to do several Java T-Points because I'm going to go right from there into an SQL tutorial on Java T-Point. Then a more specific SQLite tutorial on there, including how to connect SQLite with Python. Then we're going to look at 2 sample databases, and actually just one that we'll probably take a look at. All right, that's the name of the article though. And both of these, all right, I apologize for that. Didn't realize my phone was still on. But when we go through these 2 databases, and like I said, it'll be just one, this is the first time we're actually going to see a full-blown SQLite database. In fact, you could use this database in virtually any relational database management system, SQLite or Oracle or MySQL or SQL Server, etc. So these both are going to work with the same database. The reason I brought in the second one is it explains what every table in here is going to be about. Then we're going to go into here and we'll start with this, a thorough guide to SQLite database operations in Python. We'll spend some time on that. Then we'll go through this YouTube tutorial that's right here. Now, when I say that, I've already watched this thing, and I'm going to kind of give you, let's move that down a little bit. Yeah, do it like that. And I'm going to give you kind of a run through with it. All right, but we'll go through this introduction to SQLite with Python, talk about this course that's out there, etc. And finally, we'll end up and we'll do a little bit of work with MySQL so you can see another way of doing this. All right, so that's kind of my roadmap or whatever you'd want to call it. So with that said, like I said, we've gone through this one, and I'm going to move to this one right here. Now, I don't know how long this tape is going to be. And if it seems like it's not very long, maybe I'll just jump into the next one, which is going to be this SQL tutorial. All right, we'll see how it goes. So what is RDBMS, Relational Database Management System? As it says, All modern database management systems are based on RDBMS. Now, the ones that basically RDBMS are the main ones are shown right here. All right. The only thing I disagree with is I've never seen a dash in there. It's MySQL is all spelled out. As it says, it's called a relational database management system, and it's based on the relational model by Dr. E.F. Codd that was presented back about 55 years ago. So data, as it says, is represented in terms of rows, tuples, records, whatever you want to call them. A relational database is still pretty much the most commonly used type of database. Typically, one database will contain several tables. Each table will have its own primary key. We've talked about this in the previous lecture. Tables are made up of fields. Fields are made up of characters. All right. Databases are made up of tables. Primary key is a unique record identifier. So if we look in here, you can see this employee ID, E1, E2, E3, and E4. Those would be, that field would be the primary key. All right. So they give you this little bit of history, and that's okay. Let's just take a look at this. This is the first time we're actually looking at this. All right. So what you should see in here is we have 4 columns, also known as fields, also known as attributes. All right. The first column is emp_ID for employee ID. The second one is ename for employee name. The third one is post, which looks like it's kind of like a position. And the fourth one is salary. Notice with salary, they've got a domain in there. What they're saying is the salary must be between 5,000 and 100,000. All right. Now, next we have 4 records. The first record is for Rahul. He's employee E1. He's a clerk and he makes $20,000. The second record is E2. That's Kapil, who's a manager who makes $80,000. The third is Mukesh, a clerk who makes $20,000. And the fourth is Manoj, peon, I love that, who makes $10,000. So we've got 4 along the top. We have 4 different fields. And going up and down, we have 4 records. All right. So next it says here, what is a table or a relation? And I'm sorry for all these ads that are in here. All right. It says everything in a relational database is stored in the forms of relations. We've started to look at this in my last lecture. The RDBMS, as it says, uses tables to store data. Tables are collections of related data entries. So in other words, they're related records. They contain rows, records, and columns, again also known as attributes or fields, to store data. Each table represents real-world objects. Like I said, it used to be that they would describe a real-world object as a noun, person, place, or thing. But now notice it can be an event or something that isn't really tangible as well. The organized collection of data is, as it says, is known as the logical view of the database. Okay. So a couple things about these relations. Each relation has a unique name by which it's identified in the database. Well, that's the primary key. Second, relations do not contain duplicate tuples. Now, it would be legitimate, it would be possible in here, in the example they show right here, to have 2 people named Ajit who are both 24 and both in this course. That would be possible, but they would have to have different IDs. That's how you guarantee that you don't have duplicate tuples. Now, the tuples, it says, have no specific order. Well, that's true, but typically they're put in an order, so they're put in by ID order. Finally, all of the attributes are atomic, meaning that each attribute can only hold one thing. So, for instance, we've got this, and it can only hold one course. If we wanted to add CA, we'd have to add another record in here. All right, so it says this is a student table. So if you notice in here, again, we have 4 different fields or attributes. One called ID, one called name, one called age, and one called course. And we have 5 records. Number 1 for Ajit, number 2 for Aryan, number 3 for Mahesh, number 4 for Ratan, and number 5 for Vimal. Okay? So a row, as it says, is also known as a record or a tuple. It contains specific information about one entity. Now, they give you some properties here of a row, and we can keep all this on the screen. No 2 tuples are identical to each other in all of their entries, so at a minimum, the ID has to be different. All tuples have the same format and the same number of entities. The order of these tuples is irrelevant. You get to them by identifying their content, not their position in here. So this is one record. This is the first one that was shown in there. So again, it has 4 columns: an ID column, a name column, an age column, and a course column. A column, as they mentioned right there, is a vertical entity in a table, so it goes across. There's one, there's one, there's one, and there's one, just like here. There's all the IDs, there's all the names, there's all the ages, there's all the courses. All right, properties of attributes. Every attribute must have a name. Well, number 2 there says null values are permitted if you allow them. You, as a designer, can make all attributes required, or you can make just some of them required, or you can say that the only one that's actually required is the ID. If you're going to do that, you oftentimes will also specify default values. Here is an example of how you'd use a default value, or why you might want to use a default value. All right, I live in Missouri. When I taught at Rankin Technical College, I was teaching at the Wentzville, Missouri campus. We have campuses in St. Louis, Ashland, Troy, and Perryville. So there's about 5 or 6 campuses. All right, so why am I telling you this? Well, to my knowledge, about 90+% of the people who go to Rankin Technical College are from Missouri. So if I had state, I could put a default value of either MISSOURI or MO, depending on how I was setting it up. And if I put a default value in, that would mean that if I don't specify a value, it'll take the default. All right. Finally, as it says, attributes that uniquely identify each tuple are the primary key. This is not the primary key. Even though these are all unique, the primary key is right here. All right. The smallest unit of data in a table is known as an individual data item. It's the intersection of a tuple and an attribute. These are atomic, which again means they must only hold one thing, and they should be drawn from the same domain. In other words, these should all be numbers, these should all be strings, numbers, and strings. All right, now this degree here, I've never heard it put quite like this, but that's what they say here. The total number of attributes that comprise a relation is known as the degree of the table. So it says here we have 4 attributes. So its degree is 4. Again, I don't know exactly what that shows you or what that's about. I've never used that before. The total number of tuples or records at any one time in a relation is known as that table's cardinality. If there is no information yet in the table, the cardinality is 0, and again, it's an empty table. So as it says, here we have, in this example you see on the screen, we have 5 rows or records or tuples. So the cardinality is 5. The domain are the list of possible values. You can specify domains in a lot of different ways. All right. One way you can specify them is by using what are basically known as typically Boolean type of values. And they use their like marital status, which could be true, false, or yes, no, or 1, 0, depending on how you set it up. Null is an interesting one right here. Null literally means unknown. So if you are one of my students, and let's say that I'm in a classroom and I'm the teacher in that classroom, and you walk in there on day 1, and you walk up and say, hello, are you the instructor? And I say, my name's Jeff Scott. How do you do? What's your name? And person says, my name is Frank Smith. Okay. All right. That's fine. And I say, wow, we get to talking, and even though I would never ask anything like this, somehow we get to talking about grade point averages and stuff. And I said, what's your grade point average? And Frank looks up and says, this is my first class. I don't have a GPA yet. That means it's not 0. 0 would mean you're failing. It means it's unknown because you don't have one yet. That's technically what null means, is it's unknown. All right. Data integrity. There's a few things in here that have the word integrity set up with them. Entity integrity. It says there are no duplicate rows in the table. You make sure that entity integrity is intact by having a primary key. Domain integrity. As it says, it enforces valid entries by restricting the type, the format, or the range of values. Referential integrity is one we could talk about for quite a while. What that means is if you've got 2 tables, and one table is basically the parent table, and one is the child table. You say, what the heck does that mean? Well, imagine that I've got a table called customers and another table called orders. Customers place orders. So customers in that case would be the parent table, and orders would be the child table. Well, as it says there with referential integrity, rows cannot be deleted which are used by other records. In other words, I'd probably set something up where I could not remove a customer from the customer table while that customer had orders. All right. So you can't remove the parent when the parent still has children, for lack of better words. User-defined integrity. It enforces some specific business rules defined by users. That means, for example, you say that you are not going to allow null values, which means you have to have a null value. You can't have nulls. You say that something is an integer, which means it has to have whole numbers. You specify a domain, which says that, as showed in the earlier example, that the salary must be between 5,000 and 100,000. Those are examples of user-defined integrity. Now that's it for this. And let me tell you, notice it says here, next topic, DBS. If we go along the side here, take it back up to the top, this is a great place to start. All right, and I'm going to jump here to SQL. And that's the next thing. And actually, it's the next thing right here, this SQL tutorial. All right, so let's take a quick look at this. SQL, some places pronounce it SQL, but usually it's just called SQL. All right? It stands for Structured Query Language. As it says, it provides, basically, it allows you to perform operations on databases. The main operations that you're able to perform, see if I can go back and find what we were working on yesterday. There we go. Character fields, etc. What we're going to be getting into in here shortly is we're going to talk about something that's referred to as CRUD. That's an acronym. And it stands for Create, Update, sorry, I missed one, Read, Update, and Delete. And if you take the first letter of each one of these, it spells CRUD. So this is create a new, typically, it's create a new record in a database table or a new table in a database. That's usually how you use create. We've got read, which allows you to read an existing record or records in a database table, but not change data. Okay? Update allows you, okay, update an existing record or records in a database table and change the data. Delete an existing record or records in a database table. Now, going along with these, there's another couple terms here that I want to mention to you, and they are data manipulation language, which is more often known as DML, and data definition language, which is known as DDL. Why am I telling you this? Because data manipulation allows you to, this works with database data and allows you to add or insert, which is basically the create that you see up above, read, but we call that select, which is the read, update, which again is called update, and delete. Database data. You're working with the database itself. Now, there's also DDL, and that does not work with the database data. It works with what's called the database schema. And that's, for lack of better words, we'll say that's the setup. All right. So the commands, the DML commands, are insert, select, update, and delete. All right. The ones that you can use for DDL, these allow you to, well, they're really, let's see, Again, they allow you to create, alter, which is like an update, and in this case, it's drop, which is kind of like delete. Database schema. Now, schema may make absolutely no sense to you right now. When we start to go through some examples shortly, I think it'll make more sense to you. At least that's my hope. All right, there we go. So you're learning a bunch of new terminology. We learned all this stuff, lines 1 through about 66. Now we're into here. So this is what we've talked about that's been new in here. All right? Okay. So, as it says, SQL, or structured query language, is used to perform operations based on the database. Things like update, already mentioned the word update, insert, usually done with a create, delete, done with a delete, etc. You can do this on tables and other things that are in a database. As it says, the QL in SQL stands for query language. It allows you to go in and ask questions. All right, so here we've got what is SQL. As it says, it's the short form of using the word structured query language. I pronounce it SQL. Some people call it SQL. We want to be able to maintain the data in our relational database management system. You know, if you can't maintain your data, for lack of better words, you're probably going to be dead in the water. All right, they say that it's a special tool used by data professionals for handling structured data. Okay, why? It's widely used and it's widely accepted. That's why, more than anything else. If you want to see the history, you can go back and take a look at this. All right, and there's even some more in here. That's totally fine. Now, you don't have to worry about this and what's going on in here. All right? Here's the major commands that we're going to talk about. Create, update, delete, select. Those are the basic DML, or data manipulation language commands, and then create, alter, which should be in here, and drop, which are the basic data definition language commands. So create allows you to make something. A new table, you know, typically is, or a new database. Update allows you to change something. Delete allows you to remove something. In all three of these, in create and in update and in delete, you are somehow changing something in the database. You're adding to it. If you're using a create, you're modifying it. If you're using an update, you're removing something if you use the delete. With select, you cannot, I want to say this again, with select, you cannot change the database. You can look at the data in almost an unlimited number of ways, but you cannot change any of that data. Drop allows you to remove something, but rather than working with data, it allows you to remove some of the schema, an entire table, or other things. Insert, as it says, allows you to add something into a database. Now, they talk about SQL and no SQL. This is a misnomer. People think this means not SQL. It means not only SQL. So NoSQL databases still allow you to use total SQL concepts if you want to do so. I'm not going to go through this because you might find it confusing. Why would you want to use SQL? Number one, you can do a lot of things without knowing any programming. In fact, in a lot of companies, you'll have database people who know nothing about programming and programming people who know little to nothing about databases. High speed, yeah, it works fast. Again, it's standardized. It's been around for 50 years. It's portable. It's interactive. It'll work. Now, it'll work with typically any kind of relational database management system. The syntax or the rules for it may be a little different in some database management systems. All right. The disadvantages of using SQL, it can be expensive. And it can be, to some people, a little bit complex to work with. But that's usually only when you first start. All right. And it says here, yeah, you might not have total control. Yeah, I'm not going to disagree with them on that. Here's the syntax. I'm not going to go through this whole thing. We just went through that, and there's that. If you want, you can go through this yourselves. We're going to be going through multiple examples of virtually all of this stuff in here. But I wanted to just go through this SQL syntax one. We should be fine for time. We are. When you want to do some work on the data in a database, you write a query. A query is a question. You're asking for information. The syntax has to be written in a certain way. So it says here some of the things to remember. You can write the keywords using SQL. In fact, anything you write in SQL, you can write it in uppercase, you can write it in lowercase, you can write it in mixed or title case. What I'm going to attempt to do in here, hopefully I don't break my own rule here, but when I start to show you examples, I'm going to take the keywords, the words that mean something, that are SQL words, so to speak, and I'm going to capitalize every letter in those. Everything else will be in lowercase. Next, the statements are dependent on text lines. It says you can place the statement on one line or you can place it on multiple lines. There are a few, unless you do this type of thing, so we'll get to in just a bit. Third, you can perform most of the action in a database with SQL statements. Fourth, behind the scenes, it's working with relational algebra and tuple relational calculus. You don't have to worry about that because, again, it's behind the scenes. SQL statements, as it says, tell the database what operation to perform. So here's an example. Let's go back to what we looked at yesterday. All right. If you remember, one of the first things that we did in here was we came in and first we had this. We had an employee. So this would be all the information for an employee. So if we want, an employee in the first case, before we broke it up, had an ID, a first name, a middle initial, a last name, an address, a city, a state, a zip code, a cell phone, a department, a salary, a work phone, and a work email. 13 pieces of data. We then broke it down. So we had 1, 2, 3, 4, 5. And here we have 9 pieces of data. All right. But the point about that is this. If I wanted to see all employee records, so if I wanted to see all my employees, there they are. So let's say I want to see, so the idea here is I want to see or view all family records. I would say select star from family, like that. And that's going to basically provide me with this. If I wanted to do the same thing with friends, it would be select star from friends. What if All I want to see from friends is the first name and the last name. I don't care about middle initial. I don't care about social security, none of that stuff. All right, so if I want to come in here and I want to see, so this would be all of the friends records. So if I want to come in here and see all friend records, but I want to see first name and last name only. So instead of star, which means show me everything, I have to list them out. So I can say first name, comma, last name. And instead of showing me all this stuff, it's going to show me Gerald Jones and Brian King, because that's all I ask for. Now it says each SQL statement ends with a semicolon. I didn't put them in. It depends on the editor that you're using, whether or not you need to put a semicolon at the end. It really does. So here's the major statements, and you'll notice they're all hyperlinked. The scribe isn't and commit isn't, but out of these 17, probably about 12 or so are hyperlinked. So if you click on the link, it's going to show you an example. Very similar to what I just showed you. I'm not going to take the time right now to go through each and every one of these. All right. So we looked at select. There's an update. So what if I just showed you the select? So going back to here, let's say we want to create it. We want to make a new database. So we've got family and we've got friends, right? Okay. There's our friends, except, and we got the states. So I'm going to come in here and I'm going to create new database, and we'll call it family and friends. Okay. So I'm going to say create database family and friends. That's going to create a new database. It will not make a table for me. It'll make a database, kind of a holder for that information. Then if next I want to create a new table, all right, I can, once that database, I'm sure it's active. So typically I would say something like use family and friends. That will, for lack of better words, make the database active. All right. Then I can come in and say create table, and we'll say family. All right. And we have to then let the system know, all right, what we're going to be putting in here. Did we have a create one in here? There's a create table. All right. Yeah, we'll use their example and I'll just fix it up. Okay. So we're going to say create table family. Now I'm going to get rid of this, so don't worry about it. We'll fix all of it right now. All right. And I'm going to move all this over. All right. And we'll say ID int. The not null is fine. Then we can make this uppercase or lowercase. It really doesn't matter. Let's make it lowercase. So ID. And then this will be first name. Copy that. Then we will have last name. All right, so there we've got, we need middle initial. Call it middle init. All right, we're going to make that a char of 1. And we're going to put right there null. I'm going to explain all this in just a minute to you, okay? So we've got the ID. Oh, we forgot the social security number right here. So SSN, varchar, looks like 11, and that'll be not null also. All right, so now we need address, varchar. Again, we'll make it, I don't know, 50, and we'll say not null. And we need city, state, zip. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So after zip, we'll have, we'll put cell phone in here. All right, so let me fix this, and then we'll go over all of it. We'll say 15 here. Now you can see how I lined everything up, as they say, like little soldiers. We did not have to do that. In other words, I didn't need all that space here, or here, or here. I just wanted to put it in like this so everything would be lined up, so you'd see exactly what I'm working with here. So what we're doing here is we're defining the table schema for the family table. We're saying that the family table, each record will have an ID, a social security number, a first name, a middle initial, a last name, an address, a city, a state, a zip code, a cell phone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 fields. The primary key, or the unique record identifier, will be that ID. Okay? So what does the rest of it mean? Well, ID, SSN, first name, middle init, last name, address, city, state, zip, and cell phone are just the names of the fields. They're arbitrary, meaning I could come up and call them anything in the world I wanted to, but they should be called something that makes sense with what I'm working with. All right? Okay. Then next, ID is an integer field, which means it can only hold whole numbers. Now, with some database management systems, you can come in here, you can add another word. Auto increment. And if you put that in, it'll basically put the first record in, it'll put 1 in, then the next one is 2, then the next one is 3, etc. All right, and I don't know if that goes there or if it goes afterwards. It doesn't really matter in the end. Okay, but it'll be a whole number, cannot be left blank, and have the system put it in and automatically increment it for me. Social security number, anything with varchar means variable character length. And I've got 11 in here if you count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now it's variable because somebody might put it in for whatever reason and not put in the dashes. And again, it can't be null. First name, 1 to 20 characters cannot be null. Middle initial. Notice it's not varchar. Var means variable length. Char means fixed length. All right. Some people don't have a middle initial, so we will allow nulls. Maybe you don't know the middle initial, or you don't care, or they don't have one. Last name, variable length, 1 to 20 characters, can't be null. Address, 1 to 50 characters, cannot be null. City, 1 to 25 characters, cannot be null. State, we're using that abbreviation. So again, it'll be a char of size 2, can't be null. Cell phone, not everybody might have a cell phone. So the not nulls are 8 of these, but the middle initial and the cell phone are both null rather than not null, meaning we could leave those blank. So this is the schema. All right, so again, this is the schema for the family table. All right. We could basically copy all of this. In fact, let's copy everything. And I'm going to bring it down here. And this can be the schema for the friends table. So we're going to create table friends because it looked exactly the same right there. All right. Finally, we have this states table. So with that one, the schema for the states table will be, of course, different. All right. We'll have an ID, which will be an integer, and then we'll have a state name, which will make it varchar. That's it. Now, what we might want to do, you don't have to do this, but we've got ID and we've got ID and we've got ID, which could get confusing. So we can call this, for example, friend ID. You don't have to do that, but we could do that if we wanted to. All right. And then this one, oh, I'm sorry, that's family ID, my fault. So that would be family ID. Then here, this would be friend ID. And finally, where we do this one, this could be state ID. So in all three cases, we're creating schema. Now, when we start to add records, so if we wanted to add these, I'm not going to add them like this. I'm going to leave off these numbers. All right? But I want to insert into a table. So I'll leave these here so you can see them, but I'm going to come down here. I'm going to copy all this. All right? And I'm going to say insert into family. All right, and I'm going to add all of the field names except the ID. That should say family ID here, and it doesn't. Friend ID and state ID, those are good. All right, so I'm going to say in here, we created the database, we created the schema, and now we want to add the actual records. So I'm going to insert into family. I'm going to leave off the ID. So what do I want here? SSN, first name, last name, oops, sorry, middle initial, all right. Now, I can put this over multiple lines. It doesn't hurt anything. Like that. Then I will say values, because these are the actual values that I'm going to put in there. All right, now I'm going to grab all these, and I'm going to make a change, so you'll see it in a minute. All right, I'm going to tab each one of these over one, and I'm going to put each one in parens, and I'm going to remove that field because it's automatically going to be put in for me. All right, so there is everything that should create everything for me. All right, and then I can go in and do the same thing here. So where are my friends? So I can insert into friends the same thing, but I'm going to change and grab these two records, get rid of all this, put in these two, tab it over. So that's how I would add the records to my table. All right, now we've got states. All right, so it's going to be similar. Oops, I don't want to do that. So it'll be insert into states. And again, that's going to be an auto increment field. So all we need in here is the state name. In fact, I'm mistaken here. This would be state ABBR, state abbreviation, and that would be a char of 2. And we're going to say that this can't be null, and neither can this. All right, and here, now we got to go back and change all these because the primary here is going to be friend ID. All right, the primary key here is going to be family ID, and the one here will be state ID. Now, let's go back and see if we can kind of fill this in fast. All right, so no, I don't want it like that. I'm not trying to buy something. Don't want that either. State abbreviations for all 50 states. There we go. We can use this. I wish I were backwards, but let's see. Well, I'm going to leave that one there for a minute. Well, there are none of them are. So I'm going to grab all 50 of these. And we'll bring them in here. All right. Now this is going to be really very ugly, but that's okay. Just paste that in. All right, so I'd have to go back and change all these. So in other words, I could make it easier. I can say the name first and then the abbreviation. It really doesn't matter. There. All right, so I can get rid of, let's try to fix these up as quickly as I can. In fact, let me pause and I'll fix these. All right, I believe I finished everything. Now, I spaced it out. You didn't have to do that, but I added tabs, etc., so it would all line up. So we've got, remember, it's auto increment, so we don't include the ID, but we've got the state name and the abbreviation. You'll notice that each one of these, in fact, each one of these should have had a paren at the beginning of them, and I didn't put them in. So I'll add those right now. I'll tell you what, so you don't have to watch me do it and probably screw it up. I'll go and do that later. All right? But you can see now with what we've looked at, how you go in there and how you go in and you basically go in and add the necessary information. All right, let's go back to where we were, which was here. All right, so if you go through these, I've shown you a couple of them. All right, and we will go through all of them. It's not that I don't want to go through them all now, but I think it'll make more sense when we've got real data that we're working with. So there's an explanation of each one of these in here, and I'm not going to go through them, as I said. All right, but I think that's pretty much everything that's in here, yeah. All right, now there are certain data types that you typically work with in here in most every database system. And typically these are the main ones. Strings, which are anything within double quotes or single quotes with some database systems. And it's characters, numeric for numbers, and date and time. Now here's some of them, and again, it depends on what you're working with. I already showed you the distinction between char and varchar. I've never used binary or var binary. Text, some of them, rather than using char and varchar, they may use text. All right. And again, here's MySQL. It doesn't matter what we're working with in here. SQL Server. I don't think they have one for SQLite, but maybe they do. Doesn't look like it. All right, the major operators. Okay, here's stuff that you can do. We're going to get into all of this stuff. Again, I'm not trying to throw too much at you right now. But this is a terrific place to start. And the other thing is you've got to be able to, when you do this, to know where to look for documentation. You probably forget something sooner or later. I still do. And I've been working with a lot of this stuff for quite a while. Yeah, then they're going to get into the create database, etc. So I've gone through what is RDBMS here, and I went through the beginning, at least, of this SQL tutorial. So when I come back, I'm going to switch gears, and I'm going to go through, in fact, let's do this. I'm going to take this, copy it, copy that URL, paste it in and put it in there again. Oops, put it in here. Okay, connect SQLite, and I'm going to bring it back to here. Then I'm going to go here, and I'm going to click over here for SQLite. Because it's time to talk about the database that, for lack of better words, kind of comes with Python. So we'll do that next. And again, that means that so far, I've gone through this. Understanding relational databases, a beginner's guide. I went through this. What is RDBMS, Relational Database Management System? And I also went through this SQL tutorial. So we're going to pick it up right here. We're going to do these two at least on the next lecture. If there's time, then we'll get into actually working with a, quote, real database, unquote. Then we'll move over to the Python side. All right, so I'll be back with that in just a little bit. Thanks.